Hello, here we are for acceleration questions and problems, set 1. We're taking a look now at problem number 3. So the calculation number 3. And that should say a light plane, a light plane must reach a speed of 30 meters per second for takeoff. How long of a runway, or how long a runway is needed if the constant acceleration is 3 meters per second squared? And so you say, all right, I understand that planes need a certain amount of space to get up to speed. They can only accelerate so quickly, so they need some room to get up to their takeoff speed before they run out of runway. So I'm trying to figure out how long we need. This seems like the sort of calculation that would be very important to some people. So again, sometimes I'll draw a little sketch. Right? And we're trying to solve for how long. Well, that's going to be how far that plane, right? How far that plane needs to taxi before it can take off, right? Okay, and so how far it has to go, how far, that sounds like a displacement to me. Okay, and so we're trying to find that displacement, delta x. We know that we're going to start, it doesn't explicitly state it here, but we're pretty sure this plane starts from rest and then has to get up to speed. No one's like chucking it or anything or giving it a shove. Perhaps it was a plane on an aircraft carrier. We might talk about how fast it's going when that catapult is done shoving it down the deck. But anyway, but let's take a look at this. So we're going to say the initial velocity is 0. We're going to assume that it starts from rest. And we know that it has to reach a speed of 30. Okay, of 30 meters per second. That'll be our final velocity. And we know that the acceleration is 3 meters per second each second. Okay, is how quickly we're changing our velocity. Every second we add 3 meters per second to our velocity. So looking at this, we've got acceleration, initial, final velocity, displacement. Do I have a formula like this? I do. I've got a formula that uses those variables. It looks like this. V squared is V naught squared plus 2a delta x. Okay, handy formula to have. We're going to rearrange and solve for that delta x. So I would subtract the V naught squared over. So I'll have V squared minus V naught squared. And I'll divide through by 2 times the acceleration. And that gives me the displacement. Now I can substitute my values in. Hey, what's my final velocity? My final velocity here was 30. My initial velocity was 0. 2 times my acceleration of 3. If I do this, 30 squared is 900. 900 divided by 3 would be 300. 300 divided by 2 would be 150. So it seems to me that this is 150 meters ought to be the length, the minimum length of runway that I need to get up to speed. You'll notice that I like to rearrange my formula before I substitute the values in, so then I'm not having to shove numbers around all over the place. This is actually, there's multiple good reasons to do it this way. And I would recommend strongly that you try to get into the habit of listing out your formula, then rearranging to solve for the unknown, and then put your values in. We will talk more in future problems why that is a good idea. All right, that's what I have to say about problem 3.